Yeah. The X and Y are the inputs. So you don't have to define them. They come in as inputs. So when I put 1 in as my first input, that defines X as 1. When I put 2 in as my second input, it defines Y as 2. Yeah, it's going to follow it. So first it will double it and put that in X, then it will double this one and put it in Y, and then it will add them. Any other questions? Yeah.
Would Z show up if we didn't suppress it?
Yes. Wait. Z shows up because it's an output, not because it's suppressed or not. So they're all suppressed, but it shows up because it's an output. If I unsuppressed it, it would show up twice. Any other questions? Okay. So there are 34 people that took the survey, and what I was most interested in getting from the survey is how you can make lecture as useful as possible. It's the one thing about this class that's new. Teaching it here at MSU is this lecture format. I used to teach this class in 2 2-hour chunks in the lab, and it was all integrated, so I didn't have the lecture separate. So I'm still kind of trying to figure out the best way to present the material in the lecture and then have you do the material in the lab, which is not my preferred way, but that's the way the class is structured. So out of the 34 people, 3 people reported that the lectures weren't helpful for the pre-labs, and 7 reported that they weren't helpful for the labs, but everyone else reported that they were either helpful. Most people found them helpful to some degree. There was a couple people that put neutral. When I asked what was most helpful for your learning, honestly, people put everything. There was no pattern. I think most people put labs, but people put lecture, people put pre-labs, people put kind of everything. And then the last thing is 29 out of 34 people who responded didn't have any problems with the logistics, hearing me, seeing the screen. So if you are having problems, I would like you to come to me and I can help you if you need to find a new seat or if you need me to change the way that I'm talking into the mic or something. I don't know. You should come talk to me because I definitely want you to be able to hear and see what I'm talking about. The best feedback that I got and that I'm going to start applying in the lectures is the 2 feedback that I have listed here. So the first thing is I'm going to experiment a little bit more with how I write the code in front of you and how I present it so that you can follow it easier. Some of you find it confusing when I add lines of code in the middle of the code. So I try to write it how I would write it, but that does mean that I'm going to jump around a lot. So I'm going to try to think about a better way of laying that out so that your notes are easier to take. And then overwhelmingly, you guys wanted me to do more complicated examples in lecture or less simple examples. So I'm going to try to incorporate more complicated examples into the lecture as well. So first thing I'm going to do today with that is go through the quiz 4 solution a couple different ways. For this one, I'm actually not going to retype out the code. I have it prepared and I'm just going to show it to you on the screen. And I'm going to run it so you can see what it does each time. So you should be very familiar with this code. Everyone took a different quiz, so I just wrote kind of a simpler version of it. So you have some data. Part A is to find the age ranges for these 2 conditions, TV less than 130 or social equal to 45, and then to find the minimum of that subset. So little techniques that you can use pretty much in all of your codes that some of you used here and there or that I showed you how to use. So we're going to go over that. Okay, so the first thing I wanted to show you is just part A. So a lot of you got through part A, and all you need to do for part A is write out a for loop that loops through every row, write a conditional in the if statement that checks the condition that was stated in the quiz, And then I think what people had the most trouble with is what to do in the middle, like what to do inside there. So what I'm going to start with is just print I. So I will be printed every time that condition is true. And so that means everything that's printed are the rows that satisfy the condition. A couple things is that you have to index the condition here. So when you use logical indexing and you're doing the whole array, you don't put that I there. But when you're checking element by element or row by row, you have to put this I index here. So I just ran it, and for the condition I have, 3, 5, 7, and 8 are printing to the screen because those rows satisfy the condition. So that's kind of the first step to doing this problem. And so getting there is good. And then from there, to go one step further, I have this next line of code, which is the same thing, but instead of just putting the index, I'm plugging the index into the age ranges. So this actually, if you just did this, this would be fine for part A because you're showing me the age ranges that satisfy the condition. So it's not pretty, it's not in a nice display statement, but I didn't specify that it needed to be. So here it's just printing all of those age ranges. Okay, but typically what we want is to be able to save them to use them for something else. So that's what I really wanted to show you the options for. So you've already done this, but with using like a find command, right? Or using logical indexing. So I'm going to show you two ways of doing it that are basically copying the find command. Okay. So this is the third option here. So what I'm doing is I'm creating an array called end, and I'm filling that array with logicals that are initialized to false, initialized to 0. So I'm setting up an array of zeros, and then logical, that command, converts them into falses instead of zeros, the number. And then when I'm inside this loop here, I'm just replacing that false with a true by setting it equal to a 1. So then when I get out of this, I have the same thing that you get when you do logical indexing. I get those zeros and ones that I can use just like we've used in previous quizzes. So that's one option that you could do. You could also do it with just zeros and ones, and then you could like always write another if statement or something. But that's one option. Any questions about that one? Yeah. Yeah. You mean 8 instead of length?
Yeah, I mean length instead of 8. So you have length of TB.
Oh, here. Yeah, definitely. You should do that. Here's another option that I think I showed quite a few of you. This is a really nice technique that you can use for a lot of different codes, which is kind of what the find command does. So I create an empty array called end, and then I'm going to add on to that array every time the condition is satisfied by setting end equal to itself and adding that element onto it. So when I run this, I get, instead of getting the zeros and ones, I just get the index locations just like the find command does. So that's another little trick that you can use for doing a similar thing. So that is kind of like 4 different ways. The last 2 are the best way to save them for doing part A. Any questions about that one? Yeah.
So that end equals displays, I guess there's display. You say it has itself and then adds I to it, but end isn't changed in the loop. So
No.
Add what?
Let me run it unsuppressed so you can see how it builds in the loop.
Okay.
So the first time it's satisfied, it just has a 3 in it, then it's going to add the 5 to it, then the 7, and then the 8. So that's the 4 times that it's run, and then I printed it again at the end of the loop. So it's just building on itself. It doesn't replace it because I have the end equals end, so it equals itself, comma, the next one. Yeah. What's the question?
What is the closed display message?
because it's an array. You're basically nesting an array inside of another array. It creates an empty array. So it's like when you, it can be used to remove an element or to create an empty array. So if you look at end, it's just an empty array. Okay, so then to move on to part B, part B was to just use the intrinsic function. So for that one, you just plug your indices into the array that you're trying to find the minimum of, take the minimum, and then plug that into your age ranges. And so it'll just print out the age ranges. You can make several variables and do this in a couple different lines, but it really only takes one line of code, and it will print out that age range. The last step of the quiz was to write it yourself, and I think for a lot of you, we've now written this a couple different times, and so this was fairly straightforward. But the idea is to do I did the sort function last lecture, so you're just going to do the inside of the sort function, which is the min. A min function basically just creates a temporary variable that holds the minimum. It has a for loop with an if statement, and it checks each element of the array against that temporary variable, and if that condition is true, it's going to override the hold min with the actual min. I also hold the indices so that I can use that later to plug it into whatever I need to plug it into. So this is the minimum function.
Hold min equals I and X.
Hold min equals x of I.
No, up above.
Oh, infinity. So you have to initialize hold min to something to get it started. So since it's a minimum, you want it to be the biggest possible number, so that the first number is definitely smaller than it. With the maximum, you could do, if you know that they're all positive numbers, you could do 0, or you could do negative infinity. Yeah.
What is the benefit of defining hold in equals I?
Because otherwise you don't know the location of the maximum. So it just keeps a hold of where that minimum was saved. So every time that condition is true, it'll also save the location. Okay, so let's move on to functions. So what we're going to do today is go through the alternate quiz, but I'm going to do a lot more with it. I'm going to do all my notes in MATLAB. So we're going to start by just going over what the up-down algorithm is. The up-down algorithm is a really simple algorithm that is applicable to actually a lot of modeling applications in mechanical engineering, the type of algorithm that's written. So all it is given an integer. We're going to call the integer n. We're going to follow the following algorithm. So if n is even, we're going to divide it by 2. And then if n is odd, we're going to multiply it by 3 and add 1. And then you repeat either A or B until n becomes 1. So that's what the whole algorithm is. It just takes an integer n, and it checks to see if it's even or odd. Depending on which one it is, it does some arithmetic to it, and it repeats that process until n becomes 1. Okay, so the first thing we're going to do is we're going to figure out how we can determine whether something is even or odd. So for this, you use the remainder function. It's REM. And I'm just going to show you how it works. So if I type rem and then I put a number in as the first input, comma 2 as the second input, then if the output of that function is 1, it's odd, and if it's 0, it's even. Because what this function does is it takes the first input, it divides it by the second input until there's a remainder. So because you're doing it by 2, there'll either be a remainder of 1 or there'll be a remainder of 0. So if there's a remainder of 1, that means that it was an odd number. If there's a remainder of 0, it's an even number. So if I just, let me just make this a little bit smaller. So I'll just show it to you in the command window. So I put in a 10 and I got a 0, so that means that it's even. And then I put in 11. It's odd, so it's a 1. So we're going to use this remainder function to determine whether the number is even or odd. That's going to get us started. Okay, so let's write the conditionals first. So let's say we're given an n value, and what we're going to do is write out the two conditions in an if statement that do the check. And then I'll just keep adding on to the algorithm. So I'm going to take that remainder function, and I'm going to write a conditional first for the odd, and then I'm going to do an else if and check if it's even. Yeah.
Let's put 2 out and then
It's what it's divided by. So the remainder function can divide the first one by the second one, so it's not only used for even and odds, but if you put a 2 in, then it can determine if it's even or odd. It's divided multiple times until there's a remainder. It keeps dividing until there's a remainder. So the algorithm says that if it's odd, you want to take the n, multiply it by 3 and add 1. And then if it's even, you want to divide by 2. So we're just going to take those n's and replace them with that arithmetic. And that's that conditional check that's going to do one or the other. So with an if statement, as you all know, it only does it one time. So it's only going to check it once, and it's either going to do this or this, just one time. So that does the first step. So what should happen when I run this and I print out n? What should I get? Oh, that's kind of hard. But what should I get? 40. So 13 times 3 is 39 plus 1. So you can see that's what gets printed out here is 40. So it just did it once. So we're going to now add on to this algorithm. So the second thing we're going to do is add a while loop and a counter. So I'm going to copy what we just typed, but this time I'm going to add a wrapper around the if statement. And what do I want as the condition to the while loop to have this keep running until the condition is met? What's the condition? N is not equal to 1 is going to be the condition. So n starts out as 13. So 13 makes this condition true, so it's going to go into the loop. Whether it's even or odd, it's going to do the division or the multiplication, and n's going to now be different. So we just saw that n was 40 the second time. It's still not 1. It's just going to keep repeating however many times it takes until it's 1. So let's first just keep that there, just that condition, and run it and see what happens. So it worked, it reduced it to 1. But what we want to know usually for while loops is how many times it took, right? So this is the next thing that we've done a lot, which is have a counter. So let's add a counter by initializing a counter to 0 up here, and then taking that counter, adding 1, and replacing the counter every time the loop is executed. And then at the bottom, I'm going to add CT so I can see how many times it took along with that it met the condition. So now when I run it, you can see that N is 1, and it took 9 times to reach 1. So that was part B of the alternate quiz. Any questions about this so far? Okay, the last thing that the quiz had was to test more than one N value. So test many N values and see how long it takes for all the N values, for example. So we're going to take this code and I'm going to copy it again. So I'm going to copy it one more time. And this time, I'm going to wrap a for loop around it. So instead of doing just one N, I'm going to make N an array. So I'm not going to pick 1. I'm going to just pick maybe 10, 1 to 10. How long does it take each of those numbers to get reduced down to 1, 1 through 10? And then I'm going to loop through all the N's. And a tip for you guys, if you're adding code like this, do you see how they're not tabbed? If you highlight the code and right-click, there's something called Smart Indent right here. And it will indent it for you so that everything's nested properly, so it's a little bit easier to look at. So now we have a for loop, a while loop nested inside, and an if statement nested inside of that. So if we want to test each one, what do we have to change about the inside of the code in order to test each one individually? Yes, you have to index all of your all of your N's. So all of your N's have to have I's by them now because there's a whole array of N's. And it will just go and do each one. Anything else? Oh, right here. And what did you say? And then you need to have your counter. You can't have one counter anymore. Now you need 10 counters. So we're going to initialize our counter to the same size as N up here, and then we're going to index our counter as well. So now instead of just having one N and one count, we're going to have 10 N's and 10 counts in the loop being tested at once. What was the question? Because first you're going to try N equals 1 and see how many times it takes for that to reduce to 1. And then you're going to have N equals 2. You're going to see how many, just said that because I'm just like keep looking around. Okay, then you have N equals 2. You're going to see how many times it takes that to reduce, etc. So there'll be a counter for each time you do it. Should we run it? So a lot of computer programmers find this algorithm interesting because it has a very unusual pattern, and there's a lot of optimization you can do to make it faster, which we're not going to do, but you can see how kind of random it is to reduce it to 1. Okay, so the next thing we're going to do is we are going to, instead of indexing it like this, I'm actually going to put a section of this code in an external function and call that function. So you can see kind of the benefit of doing that. So what I'm going to do is copy it one more time, comment it out. Okay. So what I want to do is, this indexing can be kind of messy with all these i's. So I'm going to take this entire while loop and I'm going to take it out of my for loop. And I'm going to go down to the bottom of my file, and I'm going to create a new function. And this is the thing that's new for functions, for what we're working on. I think most of you understand that you can write functions in different files. So I could put this in another file. But if you just put two functions that are opened and closed in the same file, it is exactly the same as putting them in two different files, except that when you put them in the same file, only this file can use any of the bottom functions. If you put them in separate files, any file can use that function. So I'll explain it to you in a second, in a little bit more detail. So what I'm going to do is, I want to be able to test ends and get out counts. That's what I'm doing. I want to try an n, and I want to see how many times it takes it to reduce to 1. So I'm going to put the whole while loop in its own function, and I'm going to take out all the indexes. I'll probably forget some, just like I forgot to put them in. Doing good. Being thorough. Because this just looks nicer, doesn't it? It's just easier to see. It's easier to tell that it's right. And now, back up to my original function. Instead of having that messy while loop in here, I'm just going to call my function. So it was called up down with one input. So my input is n of I, and my output is ct of I. And it's the same thing as what we just had. So I'll run it again, and okay, output argument not assigned. I didn't initialize count. I should have let you figure that out. So it's trying to access count here when it's doing the counter, but it doesn't have a place to start. So it's saying it doesn't know what count is. So I need to initialize count in my function as 0. Also, really shouldn't be using the same variables here. I'll explain that in a second. So let me try it again. Forgot to initialize count. So now I should get the same thing I had before when I did the while loop. It's the exact same code, it's just written in a little bit different way with functions. So the thing I want you to see with writing it in this separate function here, nested, or not nested, underneath the original function, is first, the top function, I have a function started here, and I have the function ended here. You can see they're connected by a line when I click on it. And then I have a second function here. Those two functions are called black boxes from your pre-lab because they don't know about each other. So when I run up down, the only thing that this function that's running that function knows is it knows what it put in and it knows what it got out. But it doesn't know about what happened inside. So it doesn't know about any other variable that was defined within this function. So if I had a variable a that I used inside this function, and then I called the function up here and I tried to use that a because I knew it was in that other function, and I tried to run it, it's going to give me an error saying that it doesn't know what a is because they're black boxes. They don't talk to each other. They only talk through their inputs and outputs. So this main function only knows what it put in and only knows what it got out. Does that make sense? Okay, let me show you the exception to that. These are separate functions, right? But if I move this end to go and nest that other function, come on, I should have just copied and pasted it. So now this function is hugging the little mini function. Now it does know. It knows about it because it's nested inside, so it doesn't have an error. So that's what you have to kind of get used to with the functions, is when the functions know about each other and when they don't. And it is, you can actually see that that variable a that I used to have turned blue. This is sort of new in MATLAB. It used to not do this, but that's because I called this a function in the external function, it made it a global variable. But you used to have to type this. You used to have to type global space a, and then it would make it a global variable. But now MATLAB does it automatically if you call variables inside another function, which is very dangerous for writing codes, but that's how it works now. So you have to be very careful with your naming conventions when you're writing functions that are nested and talk to each other because of that. Okay, I'm going to take out these a's, and I want to show you a couple more things with this. Oh yeah, question?
How does the code on top know what up-down is when you don't define it until line 74?
Right, so that's the other thing. Computers always read code from top to bottom, and so if this was a variable, it would not work. You'd need to define the variable at the top. But functions that are inside the same file are operating as if they were two separate files. So just like if you have a bunch of different files, you can call them inside other files. You can also put functions listed in any order. And because they're defined as functions like this with these wrappers, they don't need to be in any particular order. You can call them in however order you would like.
So it's kind of like it's starting at line 74 and early at the same line.
So if you try to call a function like this, it will search the entire file for that function before it gives you an error. It'll actually first search the file, and then it will search the folder that it's in if it's not in the file. So that's what I wanted to show you. I can take this out. I don't have to have it in this file. I can take this entirely out, and I can save it as a separate file. Save it as up-down because that's what I want to call it as. I'm saving it in the same folder. So now it's no longer in this file. I took it out. It's no longer there. But if I run it, it will still work because it's going to find it inside the folder that that file is in. So it works the same. So you guys, when you're writing Lab 5B, for example, so sorry, the mic is probably horrible. You can either write all your functions and put them all in the same file, or you can put them all in separate files. Now the only thing is that if you're ever submitting a quiz, you always have to put them in the same file. You can't give us a bunch of files. So you do need to make sure that you're comfortable putting multiple functions in one file. Okay, but I did want to show you one tricky thing kind of related to your question. So let's say that I'm nesting the function and I'm defining a variable a here, and I want to call it here. So I already showed you that if it's nested, then it becomes a global variable and it will know about that a. So you can see it has no problem. I'm calling a here and I defined it in the other function. However, it will not work if you put a before you call the function. So you have to call the function first before you can use any variables that are defined in that function that have those global variables. So that's one little trick with them. Any questions about any of that? So what we just talked about is what this idea of a black box is, how if the functions are separate and not nested, then those functions don't know about each other's the inside of each other's variables. It only knows about the inputs and outputs. To get around it, you can nest them, and then you can create global variables. And then additionally, you can put functions in the same file or in different files, and they act exactly the same, with the exception that if I put the up-down function in this file and I don't have it in a separate file, I can't call it from another file or from the or from the command window. It doesn't know about it. You guys have any questions?
Does the function have to be called in a loop, or?
No. Nope. I could call. So I already saved the up-down function as a file, so I can just. Maybe I was desperate to know how long 30 took. I can find it now. So it's just your own function now. You can use it from anywhere if it's in that separate file. Any other questions?
So you can't have A above the function you're calling then?
Right. If it's defined in that function, yeah.
Okay, so where do you start the function and put A in there?
The function was defined in the loop, and I called A above the loop. So I had a question on the midterm exam review that was about this, about two different functions. It was the debugging one. I wouldn't put that on the exam, just so you know. I'm sorry that I didn't catch that was so early. This is like very new material, so I wouldn't put that on the exam. I just taught it to you right now, and the exam's in a couple hours. So all I want you to know with functions, I want you to make sure that you know the idea of inputs and outputs of functions. You know how to put things in. You know how to define outputs. You know that if there's an input, that means that the code knows about that input. That's all you need to know for the midterm. I don't know. I don't know if you can. I mean, you can, because MATLAB has optional inputs, but I don't know how to do it.
Can you try and see if you need that comma in the
Oh, yeah. So what I'll do is add a second one here.
you had it on the Where is the midterm?
Read 108, I think. Yes, you need the comma. I think it's 108. No, it's read. Yep.